Now, what do I do if I have mixture of numerical and categorical variables? Yeah, that's another interesting thing. So in order to explain this, let me go to university dataset and let me show you that. So this is your university dataset. You have the different universities and you have the various features such as SAT score, top 10 acceptance ratio, student faculty ratio, expenses and graduation rate. If I have all numerical data, it's very easy to calculate the distance. But if along with this data, if you have a categorical data in this way, a categorical variable rather, how would you group the related universities together? Yes, so you have male and a female. So you're going to convert this to, all right, you're going to convert this to dummy variables. Let me see that. If you have a dummy variable, you'll be writing male as 1, female as 0, male is 1, 1, female is 0, and then you have male 1, female 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1, sorry, 1 and a 1 and a 0 and a 1, 0 and a 1 and a 1. So you have this data, right? Now, this is a dummy variable that we have just created. When you create this dummy variable, and then you can calculate the distance, no doubt about that. But when you create a dummy variable, what is the range of this data set? How do you calculate the range? Range is equal to maximum value minus minimum value. The maximum value in this data set is 1. Minimum value is 0. So if you say maximum is 1 minus minimum is 0, the range will always be 1. But since all these different variables are in different units, you need to standardize the data. If I standardize all these variables, SAT score, top 10 acceptance, student faculty ratio, expenses and graduation rate using z-value, then I would get a range of all these values which will be different than 1. So the data will not fall between 0 and 1 as in this dummy variable. So again, I get into scaling issues. What do you mean by scaling issues? This might be in a range of 0 to 1. This might be in a range of probably minus 2.5 to plus 2.5. We don't know. So it will be of different range basically. Since we are creating a dummy variable which is in the range of 0 to 1, all these other variables should also have a range which lies between 0 and 1. So the formula to standardize the data in such a way that its range is in between 0 and 1 is as follows. X minus minimum value of X divided by range. X is a random variable. Think about this graduation rate. So you need to calculate the minimum value of this graduation rate, right? So let me check. So for this graduation rate, if you want me to calculate the minimum value, the function in Excel is minimum value of this graduation rate is 67. All right. And range is maximum value minus minimum value, right? So if you want me to write it for you, it is going to be X minus minimum value of X divided by maximum value of X minus minimum value of X. So here this is X, the minimum value is given as 67. If you want to calculate the maximum value, the function is maximum value of this column is 97. So if you want to calculate this, it will be simple. For this value, it will be 94 minus X minus minimum value is 67 divided by 97 minus 67. Yeah, you get a value which happens to be probably whatever be it, you'll get a value. For this second entry, once again you see 81, X minus minimum is 67 divided by range, which is 97 minus 67. In this way you keep on solving. If you keep on solving, you'll get different values. Yeah, you get different values. And if you look at the range of that, it will be from 0 to 1, similar to the dummy variable. And then you'll not get into the scaling issues. And then you'll not get into a problem wherein, dummy variable is in the range of 0 to 1. This new variable is in the range of minus 2.5 to plus 2.5. You'll not get into all that issues. All these variables, including your dummy variable, will be in the range of 0 to 1. If you standardize using the function or formula divided by maximum minus minimum value. Why do we do this? Because we don't want the distance formula to be, influenced by the scaling value. Because if you do not do that, expenses will have a huge influence on the distance. And we know for a fact that everything is equally important. And why do we do this? Because we are creating a dummy variable. If we have numerical and categorical variable, we need to create a dummy variable, because otherwise you'll not be able to calculate the distance. If I were to calculate the distance, can you ever calculate the distance between male and a female? Categorical variables. Square root of y2 minus y1 whole square. How do you calculate for categorical variable? We cannot do that. Hence, we are creating a dummy variable wherein we are saying that male equal to 1, female equal to 0. Male equal to 1, male equal to 1, female equal to 0. You're just giving a dummy variable. Yeah, that is why the name dummy variable. Alright. Once you have this dummy variable is in the range of 0 to 1. And if you standardize the other variables which have different units, you will get a different range. If you do not want a different range, and if you want a range of all these variables to be between 0 and 1, we use the function x minus minimum by range. All right. Say you have another variable such as car make of the car. You have a petrol vehicle, diesel vehicle, LPG vehicle, CNG vehicle. And you have all these values which are getting repeated. You have only these 4 categories assumed, right? If you have only these categories, one way to create dummy variable is 1, 2, 3, 4. If you're telling petrol equal to 1, always petrol, wherever you get petrol, it will be 1. If you say diesel is 2, wherever you have diesel, you'll put 2. If you mention that LPG is equal to 3, wherever you have LPG, you'll say 3. If CNG is 4, wherever you have CNG, you'll put 4. And this trend will simply continue. So, it's not going in that way. Let me copy and paste. Right? That is how you do it. Sorry. Or you create dummy variables in this way. Dummy underscore petrol. And this is the reason why you have to give more preference to ratio data. Remember, nominal, ordinal, and interval and ratio. If you have ratio data, you can perform a lot of analysis. That is why when you do data collection, when you do some analysis to determine what input variables you have to consider, then you always tend to look at the continuous data because you can do a lot of analysis without getting into this rigmarole of all this analysis. Okay, so you have dummy diesel, create a dummy variable for LPG, you create a dummy variable for CNG. Since you have petrol for this entry, you'll say petrol is 1, rest of these are zeros. Since you have diesel here, you'll say diesel is 1, rest of the entries are 0. And since you have LPG here, you'll say wherever I have LPG, I'll put a 1, rest of the places it'll be 0. For CNG, it'll be 1, for rest of the values it'll be 0, and then you can start repeating that. So if you see here randomly, if you pick this LPG, wherever you have an LPG column, there you have a 1. So in this way you try to calculate. And how do you calculate the distance? Now very simple. If two records are the same, weight will be, or the distance value will be equal to 0, otherwise it will be 1. So for example, if you're calculating the distance between record 2 and record 6, since you have petrol in both these places, distance will be equal to 0. And if you're trying to calculate the distance between, say, record 1 and 3, since they are dissimilar, distance will be equal to 1. Distance between record 1 and 3, since petrol and LPG are dissimilar, distance will be 1. Distance between record 2 and 5, since these two are dissimilar, distance will be equal to 1. If they are similar, distance will be equal to 0. So as in how the categorical variables increase, and if you're going with the dummy variable concept, the number of columns will increase. That's a problem that we need to deal with. And when you have these dummy variables that you create, there is no need to standardize. Why is there no need to standardize? Because all of these have the same unit. And what is the range of these dummy variables? What is the range? 0 to 1, right? The range is 0 to 1. And if you look at the other input variables, right, such as acceptance ratio, student faculty ratio, expenses grad, those are all in different units. If all these inputs are in different units, how do you standardize it? Normally you might be tempted to say that it is Z is equal to X minus mu by sigma. But as I've already told you, if you're going to standardize using this formula, the range will be different. When I say the range will be different, the Z value theoretically ranges from minus infinity to plus infinity. So if you calculate this using Z value, if you standardize this and this and this using Z value, you'll get a range which is other than 0 to 1. Your dummy variables are in the range of 0 to 1, but the other variables are in a different range. Again, there is some scaling issue going on, scale problem. Hence, if you use dummy variables, what is the formula that you use to standardize these variables? X minus minimum value divided by maximum value minus minimum value. When you standardize using this formula, all these other variables will be in the range of 0 to 1, and all the dummy variables that you have created are also in the range of 0 to 1. Now you have a common scale. If you have a common scale, you can build or you can proceed with your analysis. And if you have a common scale, no variable has more influence than the other variable in calculating the distance.